So hi guys, today we are going to build phase 1 of my smart wallet, and this it's not gonna be a wallet, it's gonna be just a security layer on top of safe wallet. And this have 4 features, and I will link a video about what it is and all. So let's start building. It's gonna be, I think, 5 to 6 hours. So yeah, let me check if I am still streaming. Wallet, and these have 4 features, and I will link a video about what it is and all. So let's start building. It's gonna be, I think, 5 to 6 hours. Okay. These are the videos that I have to send. Yeah. So let me turn off the camera because I am using my Mac as a secondary device. Like, I have a monitor attached to it, so I have to, start off video captures. So here we are. Run the feature documentation. Understand what you are building. Understand why that's not are we defending secure, clean, solidity, test and all those things. You write code here. Where you write code. Think about where does data live, contracts. Well, how do I evaluate policies? How do I test use cases? I think I've read this. Not testing as cases, zero max negatives. Expect code to be perfect on first try, right? Test, refactor, test again. Okay, let's read the docs. Feature 1. What it does: block transaction what that exceed your configuration. Its spending limit policy, max spending threshold 1/8. US tries to send 5 result transaction blocks, and user can quit via delay mode for 24 hours. Stores the threshold, manage 24-hour time log on changes. 3 components: policy, storage, execute transaction, goes to policy guard, check transaction, policy guard calls policy engine dot evaluate. Okay, transaction is sent to guard, and calls engine to evaluate. Policy engine read policy storage, what it is, and whatever we have set. Policy engine check 5 Ethereum, yeah, it's yes. Policy engine return decision dot require delay, require queuing, what queuing, what policy guard reverse direct execution. How it works: Policy storage. There's a peacock in my balcony, I guess. Whatever. Policy storage, policy storage, and deploying the contracts. Yeah, engine is being deployed, and these three are being deployed. Guard calls in the engine call storage, and this way, like recursion type. Safe owners sets. Okay, policy memory policy. Standing threshold 1/8 active true must go through safe multi signature. True value data schedule update and encode. Wait 24 hours safe dot execute transaction. Now set the guard. Save dot set guard. User uses delay path. Transaction is stored with unlock at user attempting transaction. Decisions required here. Oh, we execute update. You are not allowed to execute the updates. Let me see. Under SRC core policy storage. Policy update schedule. Okay, whatever function. Schedule update. schedule a policy change takes effect after time lock duration, and we have we decided. Time lock duration 24 hour. Okay. We will be taking from this railroad pending. Whenever you are calling for update, then pending update storage pending message dot sender. If pending execute after this is a good way to so basically what this policy storage is. So let's say you have set for feature 1, let's discuss. So we have set $5 standard limit. Above $5 you cannot made a transaction. It will go into queue, and it will go after it will happen. Let's not focus about that. Let's focus what this feature is. So this feature is like if you have set $5 and let's say someone is trying to withdraw $6, then they cannot do that because there is a time lock feature. Like after 24 hours only you can create a new threshold point, and this is how it's protecting. So first of all we have some mapping thing. Let's get here. So here we have a function to schedule an update, and here we will just take current timestamp and send it to a pending update map here, not in the current one because we have not enforced it right now. So it will be in pending. Then after 24 hours you have to call it again, and it will check if the last time we have requested have passed like 24 hour or not. If it's passed, then it will update in the current current policies, and if it's not, then it won't. So the downside of this feature is you cannot do anything in your let's say you have $1,000 in your wallet and you have set and the $5 limitation, then you cannot withdraw after before 24 hours. There is no possible way. Like you can make multiple transaction, but the thing is in feature 4 it will also address that feature. So I think it's more of like a limitation rather than the here's the thing about blockchain. if you are into it, then there's gonna be some downside. Like banks, they can lock your account or something, and if you are really important person, or let's say you really need that, you can go to some bank and they may unfreeze your asset. But here there is no possible way you can withdraw that money. So yeah, this is the downside of this wallet. And I am thinking of some other way, clever way to secure yourself. Like if someone got your private key or something, for that we have in feature 5, but let's not discuss here. Let's read another uh, architecture. Yeah. I think I've read this. Yeah, Underdogs feature 1. It's completed. Time lock, why 24-hour? Threat 1, owner key compromise. Steal private key, immediately disable protection. Defense 24-hour time lock. Flash cancellation feature. Risk medium, require compromise 2 plus 24-hour to act. Phishing. Trick user into signing a large transaction. Defense threshold blocks will require delay. Risk mitigated, user has 24 hours to cancel. Send token via ERC transfer, value 0, none in feature 1. Yeah, if you are transferring ERC token instead of ETH, then it's gonna be value 0. Risk known, fixed in feature 5, transfer as value 0, so doesn't trigger threshold. They will see in feature 5 notice. Chunking attack, send 10 times instead of 1. We none in feature 1, we have rapid transition detection. Delegate call, private escalation attack. To malicious contract. Defense hard block by policy engine. Delegating a call is not allowed, and it's dependent in policy engine. Let me check. We had one other module that was what that was guard. Yeah, policy guard. Guard removal. Owner calls safe dot set guard address 0. Safe level limitation none. Via event seller requires safe owner signature anyway. 0 threshold. Spending threshold type 2 into 56 dot max. Active true. So if someone don't want their wallets to be drained completely or even a single bit, then you can set the threshold to 0. Max threshold, max active, allows any amount, no real limit. Yes, equal to protection of, yeah, that is it. Inactive policy. Threshold is ignore all transaction allowed. Yes, user can temporarily disable protection. But but to disable the protection you have to wait for 24 hours. So like there is a really drawback. Why not, let's say I want to spend, I have set limit for $5, and let's make it really complicated. So if someone is trying to withdraw like $10, then they should be allowed to like 50,000, like $150 with delayed permission, something like that. Some kind of flash loan. No, some kind of flash loan feature, like you have to return those $45 with some other coupons. I really hate mosquitoes, you motherfuckers. I want to write the code. All the AIs sucks, man. Guys, okay, let's mint some Sepolia wallet, base Sepolia faucet. Although I should be using okay, I forgot, totally forgot. Okay, yeah. No, not the account. Sepolia. Network is base Sepolia. Default RPC URL. Chain ID. Currency. It's an ETH. Yeah, that is that. Block Explorer, let's say. Hmm. I have faucet is empty. I had some. Let's see. Okay, we'll focus on Okay, right now we will deploy on ETH Sepolia instead of base because we are not getting some. Owner calls safe, set card address of this protocol. One safe transaction signed by user. Owner, sorry. Message.send and check transaction. Okay, we will see the safe owner calling set safeguard address 0 to this card. Okay, we will see about that. Policy violated, zero address engine, transaction blocked. Okay, check transaction address to this is save or check transaction to value data enum dot operation gas price, gas token, base gas, safe transaction gas, refund receiver. Policy engine dot eval. called by saved after transaction execution, used in later feature rapid transaction tracking and anomaly detection. Hmm. Okay, you got lost in something. Evaluate a transaction context against account active policy enforcement action. Okay, whatever. Function dot evaluate. Where is execute? So we were evaluate context policy engine. Transaction. Ah, play feature one is complete. Anything else left? No. Interfaces I will create later. Tests, integration test, nothing. You see policy engine. Let's first check policy. Address concept. This is policy storage, and we have policy storage. Okay, we are only testing policy storage here. Let's work on feature 2. Basis point in 1000 data flow. User tries to send 60 from 100th wallet. I don't like. I was just asking for some help, and now AI is shipping my 80 to 90% of code. I don't like it. Let it fix. Let it ship. Then I will fix later. 2-minute break. I hope not. 5-minute break. Hmm. It's always going to execute. Uh, let's see the card. Check transaction, evaluate context. Schedule update, execute. Execute update. Have you its status? False engine, falsy storage, falsy card also, falsy engine and storage. Falsy storage. Cancel update, we don't have to do anything. Schedule an update, we don't have to do anything here. Yeah. So before executing a transaction, we have to check if pending, no pending update. If any kind of update is pending, we are not allowed to what? Oh, if doesn't exist. Oh, yeah. I think there is a bug here. If there is some kind of pending, let's say I have applied for some policy change. Where? Yeah, schedule update, and this is what gonna do is it's gonna do something here, and after 24 hours something is gonna be in pending. I'm sorry. After 24 hours, okay. Message dot sender. What we will have, some dot exist. Okay, dot exist is true. False. There is no pending update. I think this line isn't supposed to be, there is no need to check for any pending, no pending update. Okay, and we are, where is constructor? No constructor. We have got to be kidding me, man. Someone applied for an update and it's gonna be true. Okay, after 24 hours it should change to false. No, it's gonna be true. If true, false. I think we can write if false, then we are not going to here because, and if it's false, by default it should be false. No, why is there? What's the logic here? By default it should be false. Boolean exist. Let's ask GPT. I think it will be better. Okay, okay, my. What the heck is going on? Sorry. Oh, now I get it. If you don't have any kind of, if it doesn't exist, then there's gonna be problem because you don't have any kind of execution. Now I get it. I don't need to follow. If there is no policy, then you are not allowed to act. We are supposed to check the 40 or 60% of the update now. Who is going to change the evaluation? While evaluating, we have to check 2 or 3 important things. It should be account safeguard will call evaluation and it will pass called transaction detail, and what we will get policy from here. Let me check. Get the policy and the policies account. Where is the heck is policies? Okay, policies store policy, and policy is that look like this. Threshold, maximum percentage of balance allowed per transaction, feature 2 in basis point. Okay, check. Transaction value is 5 into 5,000 or 50,000 account balance. F is drain BPS. Okay, so we are getting the policy. No operation when protection is inactive. The policy is inactive. True, false, done. Decision dot allow, and where it's the decision, brother? Decision is of type decisions, and okay, allow block, so we are returning allow. Transaction dot operation, ctx dot operation, ctx dot count. Whatever we are transaction. CTX contains these things. We are getting type of decision, allow, not allowed, blocked, and reason code. Okay, and under CTX what we are passing here is of type policy engine. don't get it. What the heck is going on? CTX is of type WL context. Evaluate context. Okay. Hmm. Hmm. I think if I wrote this code, it would have been better. Okay. How the heck can you assign? It's fucking wrong. Oh, sorry. Pardon my word. Let me change this. It's wrong. It's pumpkin wrong. Pumpkin wrong. Hmm. On ctx dot account, you are getting the policy type. Yes, now it makes sense. for an address. The key is address here. Sorry. Evaluate if anything is allowed or not, and check the threshold and all those things. This was for feature 1. Then if decision, where is decision, bro? Okay, yeah, decision is allow, block or delegate, delay, block or require delay. Then transaction is policy violated, policy engine, and what case it will policy eval context. I've dot account, I get it. Where the heck is dot operation? There is no dot operation. Account to value bytes. Oh, there is operation. CTX dot account dot balance. Address dot balance will give the balance of the random. In all such cases, are delaying. So we have called the either if it's there is a delay or block, transaction block, region code, whatever the was region code, and revert with policy violated region code. the same thing, that is check the transaction and check after transaction. Mark contract no. Okay, we are how much token have I used? Have we completed balance uses total cost total duration? In 20 minutes I have consumed $3.66. What the heck? Claude is too expensive, man. I'm not gonna use it. Let me take a mini screenshot. Let's see what features I have added. Feature 3, 2, 1, 2, 3. Okay, we are going to write manually. How much token did it really used? Claude Haiku for Opus 6 into 10,000 token, 30,000, 60,000. What the hell? I should stocks. Okay, let's do manual coding here then. Sign in with GitHub. Okay, let me disable my screen sharing for a bit. Everything is failing. I think I should need to restart the system. Okay, failed to sign in with GitHub. My copilot isn't working, and I've used all my credit in last 20 minutes. Let me take a break.